the second part of the space physics, which involve the stars in the universe. So in this topic, you will learn about the star cycle, how stars are formed, different types of stars, different classes of the stars, and what effect the size of the star, how the stars changes from one phase to another, as well as the universe, expansion of the universe, and at the last, the Big Bang Theory. So these are the topics which you will find in this part, which is about the stars and the universe. So this is the sun. Our sun is also a star. And basically, what happened, what you will find, sun is known as, because there are different classes of the star, sun is refers to a stable star. What is the meaning of a stable star? A star is said to be a stable star when it does not change the size, because some of the stars might collapse, means the size will decrease, and some of the stars, the size might increase, they become giants. So, and if the star collapse, it will be a dwarf, but if its size increase, it become giants. But if the size does not change, what kind of star that is known as? That is known as a stable star. So our sun is a stable star, and why we say it's a stable star? Because the size of the sun is not changing. Size is constant. On average, the size is constant or not changing. And why the size is not changing? There are two pressures are there, or two forces are there. The stars, the main reaction which happen on the surface of the star is a nuclear fusion. Means the lighter nuclei join to form heavy and it releases the energy. As a result of this, it tend to emit out radiation, and that radiation is known as so because of this radiation there will be a pressure, and that pressure is known as the radiation pressure. So due to nuclear fusion reaction, the lighter nuclei join to form the heavy, and the star tend to emit out energy, and due to this energy it create a pressure which is known as the radiation pressure. But because there is a matter, there is a mass, like molecules, particles are there, and due to these particles, there is a gravity, and gravity will attract the things towards the center. So due to the nuclear fusion, there is a radiation pressure. And due to the mass, there's a gravity, and gravity is pulling all the things towards the center. So as a result, what will happen for the stable stars? Why the star is stable? Why the size is not changing? For stable stars, the radiation pressure, which is generated due to the nuclear fusion, balances with a gravitational force. So when the radiation pressure and gravitational forces are balanced, or radiation force due to radiation balance with the gravitational force, the star won't change its size. It will remain same in size, and we call that as a stable star. But what will happen if a radiation pressure is higher than the gravitational force? What will happen to the size of the star? If the radiation pressure is much higher than the gravitational force, what might happen to the size of the star? If this radiation pressure is more than the gravitational force, it will increase, decrease, or
It
remain
would be
same.
smaller.
If radiation pressure is more, like the thing which is pushing out is more than the pulling, gravitational force is pulling
So it
to all the things
becomes
towards the center,
bigger.
and radiation is pushing all the things outward. So if a radiation pressure is more, the size of the star will increase, and that type of star we call it will become a giant, red giant, blue giants, but it's called a giant star when the size start to increase. But what will happen if the radiation pressure is less than the gravitational, like gravitational force is stronger? So as a
So
result,
it will become smaller.
it will become smaller. When the star becomes smaller, the size of a star changes, then it leads to dwarf. means like it changes to dwarf. So a star might change to giant, it might change to dwarf. It depends on which one is more, radiation pressure or the gravitational. So for sun, right now for us, for our sun, the radiation pressure and the gravitational forces are balanced. As a result, it won't change its size. So what's basically happened for our sun, as it is a stable star and it's powered by a nuclear fusion. Nuclear fusion means like lighter nuclei joined to form heavy, which is converting hydrogen into helium. So hydrogen atoms which are there, these hydrogen atoms are turning into helium. Isotopes of hydrogen are there. They are converting into helium, and as a result, it produces heat energy as well. And because of this nuclear fusion, it's emitting out energy. And most of the central part, because it's as it is emitting out energy, most of the central part of this sun is actually a plasma. What is the meaning of a plasma? Plasma means like we have positive and negative charges. No, sun was not always stable. That we will discuss in a star cycle, that how our sun formed. It was never stable. Every star is having a cycle depending on what is the starting mass of the star. Some of the stars start with a very small mass, some of the stars started with a very high mass. So we will discuss later in this chapter how the sun actually, the like birth of a sun, or we can also say the formation of different types of stars, the cycle of the stars as well. That we'll discuss later in the chapter. But right now, it's just the topic is about sun, so we are only discussing about sun. So what happened due to a nuclear reaction? The central part of a sun is actually consists of a plasma. What is the meaning of a plasma? Plasma means like charges are there, overall net charge like plus and minus, like proton, electron, positive ions, and electrons are there, and that phase is called a plasma. Overall, it is neutral, but these charges are there as lot of heat energy is released. Like first we have a solid, then a solid state changes to liquid. A solid turn into a liquid. When too much energy is supplied, liquid turn into a gas. And when gas we supply too much energy, the gas will turn into a plasma. So actually, the central part of our sun is the plasma, which contain the charges. And that is releasing, like nuclear fusion reactions, releasing energy, and the gravity is pulling it together. And as you can see, how much like, and there's a collision between these particles as well. So it's about 100,000 years for the energy to release to reach the sun surface, like moving from the core, like this is the core of the sun, and this is the surface of the sun. So how much time you can just imagine. So you can just imagine from the core, the center of the sun to the to its surface, how much time it is taking. It is taking about 100,000 years to reach the energy to the surface. And when this energy reaches the surface, it's like the amount of energy which is coming out is small as compared to what was released, as some of the energy is absorbed by the particle. So variation in temperature is there. The temperature at the surface of the sun is 5,800 or 6,000 Kelvin. But at the core, the central core temperature is about uh, 1.5 into 10 raised to power 7 Kelvin, which is a very high temperature. So core is at very high temperature, but as this energy, it takes time, like some of the particles which are there in between absorb that energy. As a result, what energy is released from the sun, or a temperature at which this energy is released, is very low. So there are certain things which you should learn the information. Like example, you should memorize the mass of the sun, the solar mass. The mass of our sun is about 2 into 10 power 30 kg. That is also known as the solar mass. Solar mass means like mass of the sun in kg. And the temperature of the surface of the sun is about 6,000 Kelvin acceptable, 5,800 is also right. How we calculate this value? Actually, there is a law which is called a Wien's law, can be used to estimate the temperature of an object from amount of radiation it emit out. So there is a spectroscopy, like measuring technique is there. As you will not learn that technique in O levels, in A levels, there are ways to work out the temperature of different stars. And using a Wien's law, we can work out that. Then what is a light year? Light year is actually a distance traveled by the light in 1 year. How much distance the light cover in 1 year is known as the light year. So light year is not a unit of time, light year is a unit of a distance. And how we can calculate the distance traveled by the light in 1 year? So we have the formula, speed is distance divided by time. So distance will be equal to speed multiplied by time. What is the speed of the light in a vacuum? The speed of the light in vacuum is 300 million meters. Or you can also say 3 exponent 8 meter per second multiplied by time. So time should always be in second as the speed is in meter per second. So light year is how much distance the light travel in 1 year. That is called a light year. So if you want to find how many meters are there in one light year, so how we can work out how many meters in one light year? So time we have, like in 1 year, we have about 365 days, or 365 and a quarter, 1 by 4, multiplied by 24, we convert into hours, multiplied by 60, we convert into minutes, and multiplied by another 60 to convert into second. So this will be the time in second, and this one is the speed in meter per second. So when we multiply, this will give us about 9.5 into 10 to the power 15 meter. So this distance, 9.5 exponent 15 meter, is also known as 1 light year. So if we say something is 2 light year away from us, it means that will be the distance traveled by light in 2 years. If we say something is like 5 light years away from us, it means that it is a distance traveled by light, or that is equivalent to distance traveled by light in 5 years. So light year is actually a unit of a distance, and it refers to how much distance traveled by the light in 1 year, which is equal to 9.5 exponent 15 meter. So the Milky Way galaxy, the galaxy in which we are living, it's about 100,000 light year. Like the length, the distance of our Milky Way galaxy is about 100,000 light years. So if we say, like example, this is the Earth, and there is an object which is, say, any kind of star is there, and we say this star is 1 light year away. So if this star is 1 light year away from us, what is equivalent to 1 light year? 1 light year is equals to 9.5 into 10 to the power 15 meter. Means the distance between this object and us is 9.5 exponent 15 meter. But there's another object. If there's another object and we say it is 2 light years away from us. Example. On the scale, it might not appear 2 light year, as the distance should be like, it should be double. But example, it is 2 light year away from us. So what does it means? What will be the total distance? So 1 light year is 9.5 into 10 to the power 15. So what we'll do, we'll multiply by 2. That will give us in meter, like example, 9.5 multiplied by 2, that is equals to 19 exponent 5. So this will be equal to 19 into 10 to the power 5 meter. So 2 light years is equals to 19 into 10 to the power 5 meter. So if anything is 3 light year away from us, we multiply 9.5 exponent 15. This is not 5, this is 15. So we'll multiply 9.5 exponent 15 by 3. If it's something is 4 light year away from us, the 9.5 exponent 15 meter multiplied by 4. If 3.5 light year away from us, so 9.5 exponent 15 multiplied by 3.5 to know what is the total distance in meters. Light year is a unit of a distance and it is references, it is the distance traveled by light in 1 year. So after the sun, it's a distance traveled by the light in 1 year, not the person. Because people cannot travel close to speed of light. It's the distance traveled by light in 1 year. So, so this is our sun. And we have Mercury, Venus, and the Earth, then Mars, Jupiter, Saturn. So how much time the light is taking from sun to reach us? What is the time taken by light? So that is taking 8 minutes from sun to us. But the next star after the sun, like sun is the closest star for us. But the next star, which is a Proxima Centauri, like there is Proxima Centauri and size is much bigger. So it is about how many light year away from us? It's about 4.2 light year away from us. That is the distance between the, because sun is the closest star, and after sun we have a Proxima, and that is about 4.2 light year away. What does it mean in terms of distance? When we work out in terms of distance, so 1 light year is equals to 9.5 into 10 to the power 15 meter. So if you want to find in meters, what we do, we multiply this by 4.2. So we'll know how much distance is there between the Proxima and the Earth. Then the Milky Way galaxy, our galaxy, which we also call a Milky Way galaxy. So our galaxy is a spiral, like there are different types of galaxies. We have like spiral galaxy, irregular galaxies are there close. So our galaxy, which is also known as a Milky Way galaxy, and it's a spiral galaxy. The position and what is there at the center of our galaxy, the Milky Way galaxy, the central black hole is there. And this central black hole is responsible for, like this is how this is a picture which is for a Milky Way galaxy, and then these are the spiral arms are there, you can see. So there is a central black hole. What is the purpose? What is a black hole? Black hole basically, it has so strong gravity that even it does not allow the light to escape. Like even light cannot escape because of very high or a strong gravity. The light cannot escape from this region. So that region, there's always a central black hole. So this central black hole, there's a gravity, and that gravity is pulling all the things together. And what is the position of the sun or our solar system is this here. And our solar system is also moving around the central black hole. All the things are moving around the central black hole. Then what is the meaning of this molecular clouds? Molecular clouds mean like in this region, mostly we will find hydrogen. Molecular clouds refers to like most of this region is filled with hydrogen molecules, like because in a galaxy there are regions where we find many charges, ions, plasma, because of very high temperature. But in this region, the molecular cloud region, mainly what we'll find molecules. And this is the most region where most of the new stars, the formation of a stars happen. Because actually what happened, it's a cycle. When one star die, it produce another star. So it's like a star cycle is the birth of one, like a death of a one star leads to a birth of another star. The black hole, yeah, black hole is actually, it's like attracting all the things around it, and it does, and even it's bending the space time and producing enough gravity to hold the things together. So this is our Milky Way galaxy. So there are millions or trillions of galaxies are there. So Milky Way is one of them. And what is the nearest galaxy after like Milky Way is our galaxy? What is our neighbor galaxy? That is also a spiral galaxy, which is Andromeda. So that's a spiral galaxy. That's our neighbor galaxy. And there are millions of like galaxies are there. So important thing, what you have to learn about this, the Milky Way galaxy, about the positions, the labels. So what is a galactic bulge is there? It's just a tightly packed group of stars within a large star formation. Like it's a place where star like very like populated area of a star is known as a galactic bulge. Like so many stars are together, that is refers to galactic bulge. And we have a molecular cloud, which are also known as the stellar nursery. Like it's a star formation occur. Mainly what happened, because for formation of a star, there should be molecules, there should be like dust together. As a result, when they all combine together, it will start to form a star. So formation of the star, how the star formed. Is it clear about the Milky Way? Anyone having a question or a doubt?
No, sir, clear.
Then formation of the star always start with a protostar. Like the formation of a birth of a star is from protostar. What is basically a protostar? It started with the interstellar cloud. And what is the meaning of it? These words which are highlighted, you should learn the definition. So what is the interstellar cloud? Interstellar cloud is a cloud of a gas and a dust that occupy the space between the stars. Like we have many stars together in our Milky Way. So the space between the stars, where we find different gases and the dust particle, what we call that space between the star, we call that as interstellar cloud. An interstellar cloud, a part of an interstellar cloud is known as the molecular cloud. What is the meaning of a molecular cloud? Molecular cloud means like it's contained mostly molecule, like a cloud of interstellar gas that mostly consists of hydrogen, and it is cold and dense. So two things are there. It should be cold and it should be dense as well. So when it is cold and dense, that part of an interstellar cloud is known as the molecular cloud. So how this happen? So a protostar is like a first step for a formation of a star. The two definition, one is an interstellar cloud, another one is a molecular cloud. Like the spaces between the stars is called interstellar cloud. And the place of in an interstellar cloud where we find mostly molecules of hydrogen, what we call that as a molecular cloud. Like the space, like all the Milky Way is having, the stars are there, planets are there. So, but the space between the stars is known as the interstellar cloud. And these interstellar clouds, there are regions in the interstellar cloud where we have hydrogen molecules and it is at low temperature, like cold is there, and it is dense. Dense means like high concentration, like more particles are there. That part is known as the molecular cloud. So interstellar clouds are all around us. And then specific part of an interstellar cloud is known as the molecular cloud. Is it clear the difference between them?
Yes, sir, clear.
So what basically happened that these the molecular cloud, they start to come closer to each other. So as the force of the gravity pulls the hydrogen molecules closer, like there are hydrogen molecules, these hydrogen molecules come closer to each other. When these hydrogen molecules come closer to each other, they collide. And as a result, when they come closer, the gravitational potential energy decrease and the kinetic energy increase. Because when particles come closer, the potential energy decrease, kinetic increase. So when these hydrogen molecules collide with each other, it start to undergo a fusion reaction, a nuclear fusion. But it's not like instantly it start. It's just things are coming together. It become hot, and when it become hot, like super hot, basically a super hot gas, which is known as the protostar. And protostar continue to grow by pulling up more material from the molecular cloud. Like, say, what happened in this region? Say this in this region, say the star is forming. So hydrogen molecules coming closer to each other, the temperature is increasing. As the temperature is increasing, particles are moving faster and they pull more substances towards themselves. Because as particles are coming closer, the gravity is also increasing, more particles are attached. So as a result, they attract more particles towards themselves and the size of the star start to increase, which is also refers to a protostar. And as a result, what will happen? That the protostar become a stable. When it will become stable, when the inward pressure is equals to, like, because of nuclear fusion, there is an outward pressure. And because of gravitational force, there is an inward pressure. So when both pressures are balanced with each other, the protostar will become a stable star. So what is a form starting of a star? The star started with a interstellar cloud and then turned into a molecular cloud, and then all the things coming together, the temperature is increasing and the size or the mass is also increasing. Once the inward pressure and outward pressure are balanced, the star will become a protostar.